Hello everyone, this is lecture 7, Continuous Probability Distributions. In this lecture, we will learn explain the difference between discrete and continuous random variable, describe the characteristic of uniform distribution, recognize when to apply the exponential distribution, translate normal distribution problems into standardized normal distribution, and find the probabilities using normal distribution table. This is the structure of lecture 7. We will first explain the difference between continuous probability distribution and discrete probability distribution. Then we start uniform, and then normal, and then exponential distributions. Okay, let's talk about continuous random variables. A continuous random variable is a variable that can assume any value in an interval. Okay, between two numbers, it can get all numbers. Thickness of an item, time required to complete task, temperature of a solution, height in inches. All these variables, example for continuous random variable. They can potentially take any value depending on the ability to measure accurately. Okay. Some of you can say that, teacher, the height of a person we say only with centimeter. For example, 178 centimeter, 180, 162, and so on. We never use millimeter there. But even if you not use millimeter, you should know that the height of a person is continuous. Because if you measure it more accurately, you can find out there 178.2 centimeter. That is why the height of a person you must consider as continuous random variable. And as you know from the previous lecture, the values of a discrete random variable can be only integer numbers. It cannot be decimal number, discrete. But for continuous random variables, the value of a variable can be also decimal number. Generally saying, if we generalize what we say about these two things, we can say that the values of discrete random variable only integer number, values of a continuous random variables are real numbers. Real numbers. It means automatically that it can be decimal numbers also. That's all about this. Cumulative distribution function, we mentioned it in discrete probability distribution. We are going to use it here for the continuous random variables also. And it's very, very important for continuous random variables. For discrete, you can calculate the probabilities without using cumulative function. But for continuous random variables, the only way to calculate the probabilities is using cumulative distribution function. That's why it's very, very important for this topic. The cumulative distribution function we sign again as capital Fx, as in discrete random variables, also same thing, Fx, for a continuous random variable x, which express the probability that x is your random variable does not exceed the value of x0. And we sign it like f, capital F x0. Same thing we write in mathematical form. This fx0, where x0 is given number, means probability of the variable x less than or equal to x0. If you want to find the probability of x being between two values a and b, where a less than b, you may use this formula. Probability of x between a and b equal to fb minus fa. Why this formula is correct? Because when you calculate fb, you calculate the probability left side from B. When you calculate FA, you calculate probability of X being less than A. If you subtract from this side, left side from B, if you subtract left side of A from left side of B, you obtain the probability of X being between these two numbers. In order to calculate probabilities for continuous variables, we need to know new thing which called probability density function. And here is the properties of the probability density function. First is that probability density function for all x more than or equal to 0. Second, the area under the graph of probability density function fx over all values of random variable x is equal to 1. It means that for a random variable, if you know the formula of density function, and after that, if you draw the graph of it over all values of x, over all possible values of x for this random variable, then the area under the graph of fx equal to 1. This is very important thing, and because of these properties, we can use probability density function to calculate the probability. The probability that x lies between two values is the area under the density function graph between two values. And the cumulative density function fx 0 is the area under the probability density function fx from the minimum value x up to x0. Look at this, fx0. This represents cumulative function for the given value of x variable, x0 some given value. And look at what we have here. This is integral from x minimum, the minimum value of x, the minimum possible value of x, to x0, to given number. And here we have fx dx. You may say, what is integral doing here? We use integral because, as you know from high school, the area under the graph we calculate by using integral. So, if you want to calculate the area, which represent the cumulative function fx0 here, less than or equal to x0, you should calculate the integral. And because area for all over all values x is 1, then you may say that integral, for this case, integral from x minimum to x maximum, integral fx dx equal to 1, because this is 1. The probability density function must follow all these properties. Sometimes it's easy to find out probability density function. Sometimes it's too hard. Then it should be given for you to calculate the probabilities. Okay? Sometimes it's easy. Using this property, sometimes you can find the probability density function. Okay. Suppose that the graph of some density function is given. This is the graph of some density function of some variable. Okay. As you know from the properties of the density function, the total area under the graph equal to 1. The area under this graph equal to 1. Yes. And if you want to calculate the probability that your continuous random variable x between a and b, you should calculate this area, because total area is 1 under the graph And so this will be the part of 1. So automatically this is the probability of x between a and b. And look at this. Here we wrote x between a and b, both of them included, equal to probability of x and between a and b. But here a and b not included. This thing is wrong for discrete random variable, but for continuous random variable, it's okay. There is no difference between this representation and this representation. Why? Because the area here, if from it you take out just this segment and this segment, which area equal to 0, as you know from high school, nothing will change. Okay? The area between a and b, or area between a and b where a and b both of them included, same thing. But don't forget, this is for only continuous random variable. There is no difference between less than or equal to. Okay, now we understood about the continuous probability distributions. We may talk about the type of continuous probability distribution. There is 3 most used: uniform, normal, and exponential. Let's start from uniform distribution. The uniform distribution is a probability distribution that has equal probabilities for all possible outcomes of a random variable. This is the situation where there is no any difference between the values of a random variable. We all consider them as equal probability. And because the probabilities are equal, we may say that the density function automatically also same thing for all possible values of x. Let's say this is the minimum value of our random variable. This is the maximum value for our random variable. Then, as you see, density function is constant. And also we know that total area under the probability density function is 1. Using this property, we may find the value or the function of density function of a uniform distribution. Important thing to know that this area is 1, and for uniform distribution, density function is constant. If our random variable, uniformly distributed random variable, changes between a and b, where a is minimum value, b is maximum value, then probability density function is 1 over b minus a. And for other values of x, which is impossible, we can say you can select a probability density function as 0. Okay? Now let's explain why we say that this density function equal to 1 over b minus a. In order to understand this, let's go back. I told you that this area is 1. And what is this area? What is this shape? This is a rectangle. The length of rectangle you may find out using subtracting x minimum from x maximum. That is, if you sign it as a and this is and b, then the length of this rectangle equal to b minus a. Okay, length of it equal to b minus a. And what is width? Total area equal to 1. So area, you know that it's calculated using multiplication of length to width. This is b minus a. What this should be in order to get area as 1? Of course, this is 1 over b minus a, because only 1 over b minus a, 1 over b minus a, if you multiply to b minus a, you obtain the area as 1. Now I think that you understand how we get the density function like this. Here is some characteristic of uniform distribution. Mean of uniform distribution equal to a plus b over 2, which represent also expected value, same thing as you know, mean and expected value. The variance equal to b minus a squared over 12. You may find out these two things using the formula for finding expected value and for finding variance for continuous random variables. In exercise session, we will solve such type of questions. Let's consider example about uniform distribution. Given the uniform probability distribution over the range 2, 6, find the mean and variance, find the probability density function, draw the graph of density function, find the probability of x being between 3 and 5. Solution. First, mu as using the formula equal to a plus b over 2, 2 plus 6 over 2, 4. Variance using the previous formula equal to 1.333, approximate value of it. Density function 1 over b minus a, which is equal to 1 over 4, 0.25, because x between 2 and 6. This is the graph of density function. Because x starts from 2 and end up with x, the length of this rectangle is 4. Then the height 1 over 4, which we found here, 1 over 4. This is the graph of our density function. And the probability of x being between 3 and 5, as you know from the previous part, it's equal to area under the graph and bounded with these two numbers. This also represents rectangle, and the length of it is 2. 5 minus 3 is 2, the length. The height is 0.25. So the area of this rectangle equal to 0.25 multiplied by 2, which gives us 0.5. We finish uniform distribution. Let's talk about exponential distribution. Used to model the length of time between two occurrences of an event, the time between arrivals. For example, the time between trucks arriving at an unloading dock, the time between transaction at ATM machine, time between phone call to the main operator, and so on. Here is the density function for exponential distribution. The exponential random variable t has the following density function: ft equal to lambda multiplied to e to the power negative lambda t for t more than 0, where lambda is the mean number of occurrence per unit time and t is the number of time units until the next occurrence, and e is mathematical constant. T is said to follow an exponential distribution if you have it's follow this density function. Exponential distribution defined by a single perimeter lambda, the cumulative distribution function, the probability that an arrival time is less than some specific time t, is calculated using this formula. You can find out this formula using the integral, using the integration of density function. Here we have direct formula, but if you need, you may find out it yourself. where E again the mathematical constant, lambda population mean, number of arrivals per unit, and T any value of a continuous variable where T is more than 0. Let's consider example about exponential distribution. Customer arrive at a service counter at a rate of 15 per hour. What is the probability that the arrival time between consecutive customers is less than 3 minutes? Here, the mean number of arrivals is 15 per hour, so lambda equal to 15. And what's the probability that arrival time between two consecutive customers is less than 3 minutes? It means that x less than 3. But as you see, when we take about average, we give it as hour. But when we want to calculate the probability of x being less than 3, we gave it as minutes. So we must make them equal measure with the same unit. For this reason, 3 minutes you must turn to the hour. 3 minutes equal to 3 over 60 hour. 3 minutes equal to 3 over 60 hour. When we simplify this, we obtain 1 over 20 hour, and which is equal to, if we turn it to the decimal, 0.0105 hour. So the mean arrival time 15 per hour and x less than 0.05 hour. Applying the formula, we get here x less than 0.05 equal to 1 minus e to the power negative lambda x, from which we obtain this and the probability like this. There is no table for exponential distribution. You can calculate this for using the calculator or by using table of the power of e. There is also a way you calculate this by using the LibreOffice. We will talk about in our future lesson. Now conclusion. So there is a 52.76% probability that the arrival time between consecutive customers less than 3 minutes is this percentage.